Good evening, students. So, how the holidays going on? I hope you've been following my lessons closely, and so we are actually continuing on the concept of electromotive force and also potential difference, which I covered in the last part 4. Today we are learning part 5. Basically, focus around the page 51 and 52. Okay, the aim of this lesson is today is to learn about in detail about electromotive force and potential difference. There are differences between them, and then to learn some equations that involving electromotive force which relate to potential difference, and then finally solve some problems, after which you have to do additional problem solving relating to potential difference and electromotive force. Okay, in the last class, if you refer at PDP 4, the last 10 minutes I was talking about electromotive force, some introduction. For today, I'm going to go in detail a bit about the concept, the understanding of it. Of course, at the end of the day, you must know the definition of electromotive force, which is at page 50, and the definition of internal resistance, which is at page 53. Alright? Then the equations that are going to involve solving problems relating to the electromotive force concept. Okay, so in the last class I talked about electromotive force concept. So if you buy a battery, okay, as you can see here, it's written over here. This is what indicated as electromotive force of the battery, okay, which I said it's not the actual voltage that you are going to get, okay, because when you fix the battery in a circuit, alright, in a circuit like this, closed circuit, some of the voltage will be lost due to the internal resistance, okay, but if you measure the voltage of the battery itself, you can see the difference between here. Here is open circuit, this is called closed circuit. So in the open circuit, to put it very briefly, alright, what is electromotive force is, if you open the circuit, that means there's no more current flowing. You measure here, you won't get anything because no current flow. But if you measure across the battery, what you are going to get is the EMF, alright, which is also related to the energy and the charges. And if you close the circuit, you are going to get voltage, which is also, we talk about energy and charge. This definition you already learned earlier when you are defining the potential difference. Okay, so today we are going to see the difference between these two for the last, recall back the info that I gave you in the last class. Okay, alright, so if you look at over here, electromotive force, if you look at page 51, indicates that the energy given to one coulomb of charge flowing through the cell or the source. That means the battery is giving out energy for one coulomb of charge. Alright? Whereas potential difference indicate the energy that is transformed into other form of energy when one coulomb of charge passes through a component or in a closed circuit. That means when this battery giving out the energy, when it's going through the source, it's going to consume this much of energy per unit charge. So this value, as I said in the last class, slightly less than the value over here. This is 1.5, the battery giving you the EMF. Across the load, it will give you slightly less, 1.4 or 1.3 or whatever, depend on the internal resistance of the battery. Okay, the battery got internal resistance, I already said in the last class, that is due to the electrolysis process. Okay, point number 2 that you're going to see is electromotive force is used as a reference to a source of electrical energy. Yeah? So source of electrical energy. That means a battery or any dry cell or wet cell, that's the reference. EMF means what is the battery giving out. Okay? Actually. But what is the component using is of course going to be less. Okay? So over here, voltage is used in reference to the electrical component in a circuit. For the component, that means if you buy any component, it's written there. Okay, that is the operating voltage of the component. If the component written as 240 volt, that means that component or that device is using 240 volts. Okay. Then point number 3, it is represented by a voltmeter reading an open circuit. So how you are going to get the EMF? You open the circuit, you measure across the battery, it will give you the EMF. If you close the circuit, you measure whether across the battery or across the component, it will give you the same value, which is slightly less than the EMF value. Okay, and then of course both are measured in terms of voltage, okay, or volt, or you also can call it as joule per coulomb based on the definition. Joule per coulomb, energy, charge, joule per coulomb. Alright, so this is what basically this electromotive force and the potential difference talking about. Okay, so you can refer that at page 51, and then if you look at page 52, they are discussing about what is the, can please refer your notes. They are discussing about what is the difference, why the ammeter reading is 0, then they are giving you the EMF, and also they are comparing the EMF and the voltage. Point number 3, they are comparing what is the work done in moving one coulomb of charge around the complete circuit. Alright, around a complete circuit, the work done is actually the voltage. Alright, and why there is a slightly less voltage over here compared to here, that's given at point 4. What is the work done in moving one coulomb of charge across the light bulb? Okay, you can see there. And then why there is a difference between the voltmeter reading? Why there is a difference here and here? This is basically because of internal resistance, which we usually indicate as R. Alright, the internal resistance. Okay, the internal resistance, this is due to the electrolyte, which is giving, take away some of the voltage. So we are going to see this, how much is taking up in terms of formula after this. Alright, so to put it in simple, if you look at now page 53. Alright, please refer to page 53. Please read up page 53 there, the last 2 paragraphs. Okay, so if we take a circuit, alright, if we take a circuit, now we are going to draw together with the internal resistance. The internal resistance we usually indicate as small r, the EMF we indicate with epsilon, alright, and then we have an external resistance, let's say R, capital letter R. Okay, so if you put a voltmeter across here, okay, this is a closed circuit. So the voltage you are going to give you is V, and of course when the circuit is closed, the current flowing is I. Alright, so this V also can be written as V equal to IR. Okay, if you open the circuit, as I said just now, what you are going to measure is the epsilon. Okay, if you open the circuit, you measure across the battery, you are going to give you epsilon. So the relationship between these, okay, when the circuit is closed, the current flowing is I. Okay, now the circuit is closed. So it's going across this resistor as well as the electrolyte resistance. Okay, so this voltage plus IR, the voltage when is passing through loss, the voltage when passing through the internal resistance is we indicate as IR. Small resistance current, big resistance current, which will give you your EMF. Alright, so your voltage, right? So this function, please remember, this function is known as voltage. It's not given there, but you have to remember voltage loss due to internal resistance. Internal resistance. Okay? Which means the voltage loss due to internal resistance is, you rewrite the equation, EMF minus the external voltage from the load, okay, which we also can write as epsilon minus V. Okay, so this is your voltage loss, current times by internal resistance. Okay, so to put it in simple, that means we have now 2 equations. This one now we can write as epsilon, since IR is V, so I can also write this. Okay, so this is the two equations that you got to remember whenever you see a problem talking about electromotive force, internal resistance. Please remember these 2 equations. Okay, you can use either one, because this is from the Ohm's law, V equal to IR, This is from the electromotive force concept. Okay, so this is a voltage loss, electromotive force, voltage from the load. Okay, right. So these are the two equations you got to remember, and the understanding. Remember EMF and the internal resistance R. Okay, so if you know this, we can solve any problem. So without delaying, we can refer this at, of course, page 53. Okay, now we can go to page 53 already. Okay, so in page 53, they are giving you this equation. So now we are going to see how to apply this. I'm going to give you one or two examples. Okay, how to solve this problem using these formulas in the electromotive force concept. Okay, so after which I expect you to solve more problems at page 54 and page 54. Okay, so I'll give you only solving for one problem. So in the next class, in our PDP 6, I'll discuss solutions for the balance problem from page 54. Okay, there's one question there. And then how, and also we also have another way of solving it, this idea by using graphical method. Okay, so that we'll see later. So today's lesson is going to be a short lesson, just how to use this equation and how to solve the problem. Okay, so I'll give you one example for this, and after that you please solve the other problems, and then I'll discuss, and then I'll move on to the graph part in the next lesson. Probably you will do it again tomorrow. Okay, so this is just a short lesson today. Alright, please look at page 54, the example 1. Okay. So the equation for you to remember, either this or this. Okay? Alright. Since the current is the same, I also can write as this. Sometimes we can write as R plus R. Because the common factor when the circuit is closed, I, external resistance, internal resistance, or this we can write as this. Okay? So please remember these two equations as well. And as you all know that I've been telling throughout teaching you for this more than a year, that whenever you are solving physics problems, things you must know is first the formula, number two, what is the meaning of the quantities, and then if you read the questions, what is given, what to find. That's a basic rule. Okay? So over here, if you look at the question, please look at the first question. This is an example I'm going to give you. After this, we're going to solve for yourself. Okay? Alright, so this is what given here. Okay, so here they put like this. Okay, voltmeter. So the question, they draw the voltmeter across like this. This is nothing. You also can do it here. It's the same. Alright, you can put across the entire circuit, or you can just put across the resistor. Okay, alright, this is given as 4 ohm. This is R, they give you as 1 ohm. And then this is EMF, given as 2 volt. Okay, the question says this. A cell with EMF. Okay, whenever you see EMF, I already told you, this is the two equations you will remember. The EMF of 2 volts. Okay, there's an EMF of, okay, here they write in the notes, they put E. It's actually epsilon. It's better to write as E. Epsilon, 2 volt. Internal resistance of 1 ohm. And external resistance, we can write as capital letter, 4 ohm. What is the reading of the voltmeter? That means they are asking, this is how much? That means they are asking the external voltage V when this is connected to a 4 ohm resistor. So, what is given? This. So, what to find is this. So, if you look at epsilon, R, and then V. So, which equation is relevant over here? Okay, if I were to use this equation, let's say epsilon equal to V plus IR. So epsilon here is 2 volt. This is what I want to find. Do I know I? I do not know I. I don't know I. Right? But I know R. R is 1 ohm. Okay, can we solve this problem? Based on your maths rule that you already learned. One equation, one unknown. But in this one equation, you have two unknowns. So when you have two unknowns, we cannot solve. So that means I have to find I. So the only way I can do is, now I try to use this equation to get the I, see whether I can do it or not. Okay, the equation is epsilon equal to IR plus IR. So epsilon, EMF, 2 volts. I do not know, equal external resistance I know is 4 ohm plus internal I also don't know, internal resistance 1. So I get here 5I is equal to 2, therefore I is equal to 2 over 5, which is 0.4 ampere. That means when the circuit is closed, current flowing is 0.4 ampere. Okay, since I know already now this, now I can go back to equation 1 to get the solution. 1 is equal to 2 is equal to V plus my I is 0.41. So therefore my V is equal to 2 times 2 minus 0.1 times 4 is 0.4. So what I get here is 1.6 volt. Okay, that means when I open the circuit I get 2 volt. When I put 4 ohm and I close the circuit I get 1.6 volt. So how much voltage loss? Voltage loss here. Voltage loss I already give you just now. I told you voltage loss. Remember this, voltage loss we always count how? It's not asked in this question. Voltage loss is IR. That means I is 0.4. 1 is internal resistance, so 0.4 volt. So the voltage loss due to the electrolytes is 0.4. So it only give you 1.6 volt in this circuit. Alright? So if there is a more resistance, then it's going to be more voltage loss. Okay, one more important thing we have to know is, remember whenever you are doing this EMF problem, this EMF value and internal resistance are fixed value. That means they can never change. Only thing can change is the current based on the external resistance. Okay, so always remember your EMF and your internal resistance are fixed value. So when you do subsequent questions, remember these two values will never change unless stated in the question. Okay, but most of the time they will give you a constant. The understanding is the EMF value and the internal resistance are constant. Okay, so with that, this short lesson I end today for you to try question 2, and then there's one more question there. Please try these 2 questions. I'll get back to you by tomorrow to see whether you can solve this problem or not. I'll give you the solutions. Then we'll move on to the graphical part to analyze this question. Okay. The next section, besides analyzing the graphical part, we also learn a little bit how to get this EMF and an internal resistance in experimental way. Okay, how do we carry out an experiment to determine an EMF and internal resistance? Of course, if you want to find the EMF, you don't need to do an experiment. You just take the battery, put a voltmeter across it, you can get your EMF already. Okay, but to get the internal resistance, you have to do a set of variation of resistance or current in order to determine the internal resistance. Okay, which is a fixed value for the battery. Okay. So with that, I end today's lesson. It's a very short lesson for you to give you time for you to try. So please try out this question, and I'll come with the solutions, and then we'll go further. And then after this, we'll be learning the last part of the chapter, that is electrical energy and power, which is a bit easier section. Alright. With that, we can end this chapter 2. Alright. So with that, thank you very much for your attention. So please try out, and good luck. We'll meet again.